So what happens when a customer calls about an order, but the stock level lives in your warehouse system and the payment status lives in finance? You can copy all that data into Dynamics 365, or you can ask your team to open 3 more systems. Neither option feels great. Here's the simple definition. Virtual entities, AU, now often called virtual tables, AU, give Dynamics 365 a live window into data that already lives somewhere else. Welcome to another Knowledge Nugget. I'm Mirko Peters from M365 FM, and today we're breaking this down in plain English. We'll start with the problem, then look at the building blocks behind it, when virtual tables fit and where they can cause trouble. Why copying data creates problems. Imagine a sales team working in Dynamics 365. They can see the customer, the opportunity, and every call they've logged. But the product catalog belongs in an ERP system. Stock levels sit in the warehouse system. Invoices belong in finance. Each system owns part of the story. For years, the usual answer was copying records from one system into another. A job might run every night and bring product details, inventory numbers, or invoice status into Dynamics 365. That sounds simple until the data changes at lunchtime. A warehouse worker ships the last 10 units of a product. The ERP system knows the stock is now 0, but Dynamics 365 might still show 10 units until the next scheduled sync runs. Your salesperson sees stock that no longer exists. Then there's the duplicate record problem. The product lives in the ERP system, but a copied version lives in Dataverse, the data foundation behind Dynamics 365 and Power Apps. When someone changes a description, price, or status, someone needs to decide which system should win. That question creates a lot of messy work. Think of it like keeping paper files in 2 filing cabinets. One in the sales office and one in the warehouse. Each time somebody changes a paper in one cabinet, they must carry an updated copy to the other cabinet. Miss one trip and the cabinets disagree. Sync jobs can fail too. A password changes, a connection breaks, a field changes in the source system. The job stops overnight, and users may not notice until they start looking at wrong or missing records the next morning. Meanwhile, the people doing the work have their own problem. They open a customer in Dynamics 365, then switch to the ERP system to check stock. Next, they open a finance tool to check an invoice. Then they return to Dynamics 365 and try to remember what they saw. That breaks the flow of the conversation. Now here's the thing, you don't always need a full copy of every record. Sometimes you only need to see the current answer while you work with the customer. For example, an account manager may need today's available quantity before promising a delivery date. The warehouse system should keep control of that number because it tracks goods moving in and out all day. Dynamics 365 doesn't need to become a second warehouse database. This is the choice that matters. Do you need Dynamics 365 to own a local copy of the data, or do you need users to see the latest data from the system that already owns it? When copying adds more jobs, more duplicates, and more chances for records to disagree, a live connection can be the cleaner path. The source system keeps the record. Dynamics 365 gives users a place to see it alongside their sales or service work. What a virtual entity actually is today. We, Udemy, are talking about virtual tables. You might also hear them called virtual entities, same concept, different name. A virtual table is a table definition inside Dataverse that points to records stored somewhere else. Dataverse knows what the columns look like, product name, available quantity, price, invoice status, but it does not store the actual data. Think of it as a blueprint, not the building itself. At first, that difference sounds small. Here are the thing. It changes everything. With a normal Dataverse table, the data lives right inside Dataverse. You create an account, contact, or case, and the record is stored there. With a virtual table, you only define the shape what columns to show and a path to where the real data actually lives. Think of a library catalog. The catalog card has the title, author, and shelf number. But the card is no, the book it just tells you where to find it. A virtual table works the same way. Dynamics 365 knows how to ask for the record and what fields to expose, but the outside system keeps the real data. The card is no the book. So when do you see this in action? When you open a view of external products in a model-driven app, or when you look at live inventory records from a sales opportunity, Dataverse sends a request to the other system, grabs the data, and shows it in the familiar Dynamics 365 screen. To the person using the app, it looks like any other table. They see columns in a grid, they open a form, and they select a record and read the fields. Nothing announces that the number came from a different application. The connection happens behind the scenes. But here, the important part. When someone views the data, it does silently move into Dataverse. It stays where it belongs. Imagine Dynamics 365 as an office with a secure video screen on the wall. Across town, another office manages a stockroom and keeps the product records there. The video screen lets the sales team see what EU team says as on the stockroom shelves without carrying every box into the sales office. The stockroom remains where the work happens. Now picture an account manager working on a large sales opportunity. The customer wants 500 units next month and they need an answer while still on the call. The account manager opens a related virtual table called Product Availability. They see the item number, warehouse location, available quantity, and expected replenishment date. Those details come straight from the warehouse or ERP system at that moment, or not from last night. Tim's imported list. The account manager speaks from current data. Dynamics 365 brings sales and inventory together into one place. The warehouse system still decides the quantity. That separation matters because different systems handle different jobs. A warehouse system tracks stock movements. A finance app manages invoices and payments. A CRM app tracks conversations, opportunities, and service cases. Virtual tables let users see outside information without pretending every system needs to own every record. You might hear the term AO runtime. AO, that simply means the moment the app is running and someone asks for data. The virtual table does now indeed fetch everything once and keep it forever. It asks for the current record when a user opens a view, searches for something, or selects a row. So the virtual table is not a new database. It is a Dataverse table that presents outside records through Dynamics 365. Next, the totems follow that request from one click on a screen, out to the other system, and back again. Behind the scenes: provider, data source, and table. So what happens after someone selects a virtual table record in Dynamics 365? Imagine a sales rep opens a list of products and types a filter out every item in a certain product group. Dynamics 365 cannot imitate. Just look inside Dataverse for those rows because the rows live outside. Instead, Dataverse sends the request through a data provider. A data provider is the translator in this setup. Dynamics 365 asks for data in its own format: our table name, columns, filters, record IDs. The outside system may speak a completely different language. The provider translates between the two sides. Think of it like a receptionist who speaks two languages. The sales rep asks for available products in English. The receptionist turns that question into the warehouse system, our TMS language, sends it, receives the reply, and presents the answer in a form the sales rep can use. Users never see that translation. Behind the scenes, the provider handles the conversation. Dataverse includes a provider for OData version 4. OData is a standard way for systems to share data over the web. If an external service supports OData version 4, it can describe its tables and fields in a way Dataverse understands. That gives you a common starting point instead of writing a separate connection from scratch. For example, an outside service might expose a collection called products with fields like product number, description, unit price, and available quantity. The OData provider can request those records and pass them back to Dataverse, but the provider still needs to know where the service lives and how to reach it. That information sits in a data source record. A data source is the connection card for the outside system. It holds details like the service address, sign-in credentials, and how long Dataverse should wait before treating a request as timed out. Think of it as the address book entry for the service. The provider knows how to speak the language. The data source tells it which system to call and how to get through the front door. Then comes the virtual table itself. The virtual table gives Dataverse a familiar shape for the outside data. You choose a table name, define the columns users need, and connect each column to the matching field from the external system. Maybe the warehouse system calls a field available quantity, while your Dynamics 365 app calls it stock on hand. That item's fine. The mapping tells Dataverse that both names point to the same piece of data. The user sees stock on hand in the Dynamics screen, while the provider knows to request available quantity from the source. Each outside record also needs an ID that Dataverse can recognize. For virtual tables, that ID needs to work as a Guido, the long, unique ID format Dataverse uses. The provider uses that ID to connect the record on screen with the record in the source system. Without a dependable ID, Dataverse cannot know which exact record you selected. Now follow the full journey. A user opens a product view and filters for items that are in stock. Dataverse sees the request against the virtual table. The data provider reads the request, uses the data source details to contact the outside service, and translates the filter into a query that service understands. The source system finds the matching records and sends them back. The provider turns those results into Dataverse table rows. Then Dynamics 365 displays the product names, prices, and quantities in the same sort of grid your users already know. The screen feels familiar because Dataverse does the presentation work, the outside system does the data work. What if the source does now attempt support OData? That items where a custom data provider comes in. A developer can build a provider for another type of service or a REST API, a database connection, or a company system with its own data exchange format. The custom provider still plays translator. It receives a request from Dataverse, contacts the outside system, turns the reply into Dataverse records, and returns them to the app. That work takes code and careful testing because the provider decides how well filters, searches, and record lookups behave. A provider can also support more than reading. The built-in OData version 4 provider supports create, read, update, and delete actions. Custom providers can support those same actions when developers build them for the external system. For finance and operations virtual entities, Dataverse can also send create, read, update, and delete requests straight to the finance and operations app. That does not mean every virtual table lets users edit records. Right actions depend on the provider and on what the outside system permits. The source system still receives the request and applies its own rules before it changes anything. So there are three building blocks behind every virtual table. The provider translates the request, the data source points to the outside service, the virtual table maps what users see in Dynamics 365 to the fields and records that service returns. Once you see those roles separately, you can also see why a virtual table fits some kinds of data much better than others, where virtual entities fit best. So when does a virtual table really make sense? It makes sense when another business system already owns the data, but your people working in Dynamics 365 need to see that data right when they're helping a customer. Picture a sales rep getting a quote ready. They need product details, current stock, maybe a promised delivery date, and the status of an earlier purchase. The ERP system owns all those records because it handles purchasing, stock movement, pricing, and fulfillment. You could copy everything into Dataverse AU. But if that copied data only exists so the rep can look at it, you're creating extra work without changing who actually owns the record. A virtual table lets the rep work from one screen while the ERP keeps running the business process behind the scenes. Let's take live product data. A product catalog might have thousands of items with descriptions, units, prices, supplier details, and availability. Sales staff need enough of that information to help a customer, but they shouldn't have to become ERP users just to answer a product question. With a virtual table, that product data appears right next to accounts, opportunities, and quotes inside Dynamics 365. Inventory is another great example. Stock changes all day as goods arrive, orders ship, and warehouse teams move items around. When a customer asks, "Can you deliver this next week?" the answer needs to come from the system tracking the shelves and deliveries AU, not from a separate list someone copied earlier. Purchase status works in a similar way. A customer service agent might need to check if a replacement part has been ordered, whether it arrived from a supplier or if it's waiting for dispatch. That information lives in the purchasing or warehouse system, but the agent sees it right next to the service case. Finance records can work well too when the goal is visibility. A sales or service person might need to know if an invoice is paid, overdue, or under review before making a decision. Finance keeps responsibility for the invoice. Dynamics 365 just brings the status into the customer conversation. Here's the thing, OU. People often ask for one system when what they really need is one place to work. Those are two different things. You can give someone a single work screen without cramming every business record into one database. Finance and operations uses this idea directly. Its OData entities can show up as virtual tables in Dataverse, so makers can build customer engagement apps and Power Platform experiences around finance and operations data without copying that data first. Depending on the setup, users can even create, update, or delete finance and operations records through Dataverse. The Finance and Operations app still applies its own business rules, and that matters because a record does more than just hold fields. When someone changes a purchase order, adjusts stock, or updates an invoice-related record, the owning system might need to run checks and rules before accepting the change. Virtual tables keep that process in the right place. External marketing data can fit this pattern too. Maybe a marketing platform tracks email opens, event registrations, or campaign activity, while Dynamics 365 tracks the account manager ATM does calls and opportunities. Showing a few selected marketing details beside a customer record gives the account manager better context without creating another permanent set of campaign records inside Dataverse. The same idea works with an outside product catalog. A company might sell products from a supplier, albums catalog, where descriptions and availability change often. The supplier stays responsible for the catalog, while your Dynamics 365 users browse current information during sales work. So ask yourself a simple question. Does Dynamics 365 need to run the life cycle of this record, or do users just need to see and sometimes act on the record while they work? When the source system owns the record and a live view helps people do their jobs, a virtual table fits really well. But keep in mind, a table that looks normal on screen doesn't automatically support every feature of a normal Dataverse table. Limits security and performance. A virtual table can look like a normal Dataverse table on screen, but don't assume it works like one. The data lives outside Dataverse, and that changes what Dynamics 365 can do with it. Before you build a process around virtual data, check whether the feature you need works with the provider and the outside system. Take writing data back to the source system. Many older virtual entity setups only supported reading AU. Users could open a record and see current information, but they couldn't edit it from Dynamics 365. Today, the built-in OData v4 provider can support create, read, update, and delete actions, and custom providers can support them too. Still, that support doesn't appear automatically. The provider has to understand the action, the outside system has to allow it, and the user needs permission in that outside system. If any one of those pieces doesn't work, an edit can fail, even when the Dynamics 365 form shows an edit button. Some Dataverse features also need stored records. Virtual tables don't support Dataverse auditing, so Dataverse won't keep its own audit history for changes to those records. If you need a clear record of who changed a value and when, the outside system must track that, or you need to bring the data into a standard Dataverse table. Dataverse Search doesn't support virtual tables either, and neither do charts and dashboards. You also can't cache virtual table records for offline work, or a field engineer using a mobile device without a connection can't rely on virtual data being available. Calculated columns and roll-up columns don't work on virtual tables either. Any calculation needs to happen in the outside system, or the data provider needs to return the finished value. For example, if you need a total stock value based on quantity and price, calculate it where the product data lives rather than expecting Dataverse to build the number later. Security needs the same careful thought. Virtual tables are organization-owned tables. Dataverse can turn access to the table on or off through security roles, but it doesn't apply the usual user-owned row security model or field-level security to the external rows. In plain English, Dataverse controls who gets through the front door. The outside system decides which records and fields they see once they're inside. For finance and operations virtual tables, Dataverse passes the calling user's identity to finance and operations, which then checks that user's permissions and row-level rules before returning the data. That keeps the finance or operations app in control of its own records. Other data providers may handle security differently. Before you expose customer, finance, or stock data through a virtual table, ask a direct question. When a user opens this record, which system checks their permission? You need a clear answer, not a guess. Performance also depends on the outside system. A normal Dataverse table reads from data stored close to the app. A virtual table sends a request to another service, waits for that service to process it, and waits for the reply. A fast source feels natural. A slow source turns a simple view into a long wait. That delay can grow when a view asks for many rows, includes lots of columns, or uses lookup columns that need extra reads. Keep virtual views focused, return the fields people truly need, and avoid treating a virtual table as a place to browse thousands of records without a filter. For finance and operations connections, Microsoft recommends keeping Dataverse and finance and operations in the same Azure region to cut down on delay. The external data also needs a GUID primary key. A GUID is the long, unique record ID that Dataverse uses. Each external row needs one, so Dataverse can tell one product, invoice, or customer record apart from every other record. If the source system can't provide a dependable GUID, this virtual table model won't work without extra effort in the provider. One more choice becomes permanent when you create the table. You can't turn a virtual table into a standard Dataverse table later, and you can't take a standard table and switch it into a virtual one. Choose the table type based on how people actually need to use the data, not just what looks easiest during setup. If you need offline use, audit history, Dataverse search, charts, dashboards, or Dataverse managed calculations, a local Dataverse table with a planned sync may suit the job better. A virtual table gives you live access, but it also brings the outside system's limits straight into your app. Choosing the right approach, window or local copy. So how do you choose between a virtual table and a standard table with sync? Start with two questions. First, who owns the data? Second, do your users always need the latest version when they open a record? If another system owns the data and your team just needs a live view while working in Dynamics 365, use a virtual table. Think of it as a window, you see through it, but nothing gets copied. If you need offline access, detailed auditing, custom reporting, or any Dataverse-only feature, choose a standard table with sync. That's your local copy. The data is stored right inside Dataverse. Virtual entities connect Dynamics 365 to data that lives elsewhere without creating a second copy. That's the magic of it. Subscribe on your favorite podcast platform and share this knowledge nugget with someone connecting Dynamics 365 to another business system.